So let's go. So we're asked to look at this diagram right here and write, well, the figure, and then write expressions for ax and ay, right? So remember the fact that this forms a triangle, right? So it forms a triangle, so you could think of it as a triangle like this with 90 degrees here, right? We're looking at the x direction first. For the x direction, we're looking at this side of the triangle. So theta is here. That means that this is the hypotenuse, this is the opposite, and this is the adjacent side, right? So what could we use to determine the length of the adjacent? For the length of the adjacent, we could just say cos is equal to what? The adjacent over the hypotenuse. And then we can transpose cos theta rather is equal to adjacent over the hypotenuse, right? And then we could say the hypotenuse times cos theta is equal to the adjacent. Therefore, the x component of the vector A is the hypotenuse A cos theta, right? So we start off there, AX is equal to the hypotenuse A cos theta. Everything is there? Everything is fine? Everything
Yes,
is
sir.
fine. And then that means now for the y component, all we would do is use sine, so that would be a sine theta. Alrighty? And then we know now, right, how can we find the angle theta? Well, it didn't ask for that, but just in case, the angle theta would be the inverse of tan, right, of the x over the y. Alright? So inverse tan, a cos theta over a sin theta. Alrighty? So that's fine. That should be okay. The next part of the question, a jogger runs 145 meters. Let me fix it on the screen. So a jogger runs 145 meters in a direction 20 degrees east of north, and then 105 meters in a direction 35 degrees south of east. We must represent his resultant displacement using a suitable vector diagram. You guys are able to do that? Alright? So we're looking at a jogger, right? He's running, let's have an axis, right? He is running 20 degrees east of north, right? So we're saying that specifically now, east of north would be in what direction here? So we're looking at the x component, right? So we're looking at this here. Let's just do that. We have a vector there at an angle, right? So we're looking at east of north, right? So it would be over into the positive y and the positive x direction, right? Since the angle is east of north, so it is literally east of the north, the angle would represent here as 20 degrees, right? And then he traveled this would be 145 meters. Then he traveled 105 meters in direction 35 degrees south of east. Alright? So what would that be there? You moved down, right? So you moved south. So 35 degrees south. Here, the angle would represent here, south of east. Okay? And this would be 105 meters. And this is 35 degrees. So you guys should be able to represent that a little bit neater on some diagrams. Alrighty? That should be fine. We're asked now to determine his northerly displacement and then his resultant displacement. Are there any issues so far? Any issues so far?
Nas, go ahead.
Repeat, let me just check the chat. Alright, so we can go ahead. Okay, so we're just looking at this. So determine the northerly displacement, right? So how would we actually start there? We need to represent the displacement of the vectors, right? So we're looking at the first vector, right, with a magnitude of 105 meters, with the direction being 20 degrees east of north, right? That means that that vector would have an x and y component, and our second vector would also have an x and y component. Alrighty? So we could find those components, right? And then we could look at the ultimate northerly displacement, combining the two y components. Does that make sense? So we're looking at this here, right? We're taking the first vector, that the 145-degree vector, right? We're taking its y component. We only care about its y component, right? And we're taking the other vector that goes down like this, the 105-degree vector. Well, the 105 degree vector, right? Let's look at the thetas, right? And then we'll be also looking at that y component, right? The ultimate northerly displacement that we're looking at is y r, right? It's not really y r per se, but complete y, right, is equal to y1 plus y2, right? So all we have to do is sign a, well, this would be cos theta the first one, sine theta the other one, and you should be able to get that, right? So what it's asking, is find the y component for the first vector, find the y component for the next vector, add them together, and we have the ultimate northerly displacement, right? And then in order to find the resultant displacement of the points, right, all we have to do, right, is have r equal to the square root of the sum of the x components plus the sum of the y components squared. All right? So we do that. And then in order to get the direction, we know that theta is equal to tan theta, well, tan rather, inverse of yr over xr. And everything should be done. So you guys should be able to use these to calculate all the answers here. I know that you guys would have completed module 1 already and move on to more complex things. So hopefully this makes sense. I can move steadily on. Any questions or concerns here thus far? The last one, the last part of this question should be easy. The last part of the question is dimensional analysis, right? So all you have to do here is make x the subject of the formula, right? After having all the other units in their dimensions, all right? Because s would be length, acceleration, right? There we know what acceleration is, right? With meters per second, so length over seconds squared, all right? And then we have x and we have t as seconds. So all you have to do is transpose using dimensional analysis, and then you should get the value of x there. Do you guys want me to find the value of x real quick? The last part is t is equal to 2s over a brought to the power of x. Sorry, brought to the power of x, right? We're trying to find x there. So how can we simplify this? Anyone?
Take logs.
Repeat, you said logs?
Yeah, take log. Take logs.
Well, you don't have to. You don't
Uh,
have to at all. Right? So when I started, I looked at a little bit of dimensional analysis, right? So time t is in a dimension of time, which is equal to L over L divided by t squared, right? To the power of s. X rather. The 2 is a constant, so we don't care about the constant specifically. We could simplify this fraction, right, to L times, right, t squared over L is equal to t squared. Right? Therefore, t is equal to t squared x. The only way that is possible is for x to equal a half. Right? So looking at that. We could also take this and say 1 is equal to 2x. And then we can find that x is equal to a half. Right? It's just dimensional analysis. We don't require logarithms to do this. So we could just do that. Is it clear enough? So hopefully this is clear enough.
you can go into one more time, sir.
All right, so I'm gonna go over it one more time.